Welcome in your math pure revision for the second secondary stage. Let's begin. Problem 1. The domain of the function f where fx equals root x plus 2 plus root 5 minus x is. Here we have function fx is the sum of the two functions root x plus 2 and root 5 minus x. So domain of fx is d1, which is the domain of root x plus 2, intersects d2, which is domain of root 5 minus x. Root x minus 2 function defined only when x plus 2 is greater than or equals 0. So x is greater than or equals negative 2. So x belong to negative 2 up to infinity, negative 2 closed, infinity open. This is d1. The second function, root 5 minus x, also defined only when 5 minus x is greater than or equals 0. So negative x is greater than or equals negative 5, so x is less than or equals 5. So x belong to negative infinity up to 5 closed is d2. Our domain is the intersection between d1 and d2. To find it, we can represent each of d1 and d2 on the number line. d1 start from negative 2 up to infinity. d1. d2 from negative infinity up to 5. So d1 intersect d2 is from negative 2 closed up to 5 closed, which is the domain of fx. So the correct answer is C. The next problem, the range of the function f where fx equals x power 2 minus 1 over x minus 1. fx is linear function. Its domain is R except 1. fx in its simplest form is x minus 1 times x plus 1 over x minus 1, which equals x plus 1. So we can represent f of x by taking x equals 0 and 1. We get 0 plus 1 is 1, 1 plus 1 is 2. So our function is represented graphically by a straight line pass through the point 0 and 1 and 1 and 2. So the range of our function is R difference 2. So our correct answer is D, R difference 2. Another exercise, fx equals 4x minus 5 and gx equals 3 power x. Then f circle g2 equals what? We know that f circle g of 2 is equals to f of g2. We can find g2 by replace x by 2 in gx to get 3 power 2, which equals 9. This equals f9. We can find f9 by substitution for x by 9 in fx to get 4 times 9 minus 5 equals 31. So the correct answer is 31. The next, in the opposite figure, the range of the function is, in our figure we have constant function formed from two parts. The first part represent 2 from y-axis, so its range is 2. The other part represent -1 from y-axis, so its range is -1. So the range of the function is the set of -1 and 2. The next, solution set of the equation log 3 of x times log 2 of 3 equals 5. On the left side, we can expand log 2 of 3 and log 3 of x as log x over log 3 times log 3 over log 2. This equals 5. Remove log 3 up and down, we get log x times 1 is log x over 1 times log 2 is log 2 equals 5. Move log 2 to the opposite side to get log x equals 5 log 2. We know that coefficient the log back to power, so log x is equal to log 2 power 5, which equals log 32. Log x equals log 32, so x equals 32. So our correct answer is A. The next, the domain of the function f, where fx equals log 1 minus x for x is, fx is logarithmic function. For logarithm function, we know that x must be positive real number, so x is greater than 0, so x belong to 0 up to infinity open interval. Also 1 minus x is positive real number diver 1, so 1 minus x is greater than 0, so negative x is greater than -1, so x less than 1. Condition number 2. 1, 2. Number 3, 1 minus x doesn't equals 1, so negative x doesn't equals 1 minus 1, which equals 0, so x doesn't equals 0. Number 3. From 1 and 2 and 3, we get x as the following. x from 1 from 0 up to infinity 1 into x less than 1 x less than 1 1 down to negative infinity x 2 and 3 x doesn't equal 0 and 1 x doesn't equals 0 into x equals 0. So at 0 we will put gap into at 0 we will put gap at 0 into, so x is belong to 0 to 1, so our domain is from 0 to 1 open, 0 open, 1 opened. The next, log a of x divided by log ab of x equals what? We know that log a of x divided log ab of x equals log x over log a divided log x over log ab. We can convert divide to times as log x over log a times log ab over log x. Remove log x up and down, we get log ab over log a. This equals log ab is equal to log a plus log b over log a. This equals log a over log a plus log b over log a. This equals 1 plus log b over log a. We can write it as log b log ab. So the correct answer is 1 plus log ab. The next, 3 power a equals 4 power b, then 9 power a over b plus 16 power b over a equals what? In the given, 3 power a equals 4 power b. The required 9 power a over b. This equals 3 power 2 all power a over b. We can replace a and 2. We can change a by 2 to get 3 power a all power 2 over b. We can replace 3 power a by 4 power b from the given to get 4 power b instead of 3 power a all power 2 over b. Power and power multiply, we get 4 power b times 2 over b. This equals 4 power, remove b with b, 4 power 2 equals 16. Also 16 power b over a is equal to 4 power 2 all power b over a. Change b by 2, we get 4 power b all power 2 over a. Change 4b by 3 power a, we get 3 power a all power 2 over a. Multiply the powers to get 3 power 2, which equals 9. From 1 and 2 we get the value equals 16 plus 9, which equals 25. The next, in the opposite figure, f circle g of 0. We know that f circle g of 0 equals f g0. We can find g0 from its graph, from the graph of fx, which is linear function. g0 equals 2, so this equals f2. We can find f2 from the graph of fx, which is quadratic function. f2 at 2 at x equal 2, f2 equals 0, so the answer is 0. The next, log a for x plus 2 minus log a for x minus 1 is equal to log a for 4. Then x equals what? The left side we can write it as log a for x plus 2 over x minus 1. Convert the difference between the two logarithm to the quotient to log the quotient of the two numbers. This equals log a of 4. So x plus 2 over x minus 1 is equals to 4. By cross multiplication we get 4x minus 4 is equals to x plus 2. Remove x from 4x, we get 3x equals 2 plus 4 equals 6, so x equals 2. So the correct answer is B. The next, fx equals x power 2 minus 1 over x minus 1 when x doesn't equals 1, and equals 2a when x equals 1, is continuous at x equals 1, then a equals what? fx is continuous at x equals 1, so f1 equals limit fx when x tends to 1. So f1 equals 2a equals limit fx when tends to 1 equals limit x power 2 minus 1 over x minus 1 when x tends to 1. This equals limit x minus 1 times x plus 1 over x minus 1 when x tends to 1. This equals 2. So 2a equals 2. From that we get a equals 1. So the correct answer is D. The next, limit 2x plus 3 over 5x power 2 plus 4 when x tends to infinity. By using the direct substitution, we get 2 times infinity is infinity plus 3 over 5 times infinity plus 4. This equals infinity over infinity. So to find its limit, we must divide both of the numerator and the denominator by x raised to the highest power, which equals x power 2. So divide up and down by x power 2 to get limit 2 over x 2x over x power 2 plus 3 over x power 2 over 5x power 2 over x power 2 plus 4 over x power 2 when x tends to infinity. At the infinity, we get 2x over x power 2 tends to 0, 3 over x power 2 also tends to 0, so the result of the numerator equals 0. X power 2 cancel with x power 2, so at the infinity limit of 5 is 5 plus limit 4 over x power 2 when x tends to infinity equals 0. 5 plus 0 equals 5, so the result is 0 over 5 equals 0. Also, we can say at first, since the degree of the numerator from the first degree, the denominator is from the second degree, so the limit at the infinity equals 0 without solving. Also we can say that the next fx equals log a of 2x plus 4 and f power negative 1 5 equals 14, then a equals 1. To find a, we must have point from fx for substitution, but in the given we have f negative 1 5 equals 14. F negative 1 is the inverse function of fx. We get it by replacing y by x. So we can say that f14 is equal to 5. Change x by y to get fx. So at x equals 14, fx equals 5. Substitute in the given function, we get log a of 2 times 14 plus 4 is equals to 5. Log a of 2 times 14 is 28 plus 4 is 32 equals 5. Convert to the exponent form, we get a power 5 equals 32. So a equals 32 power 1 over 5, which equals 2. So our correct answer is 2. The next, limit when x tends to 0, 5x cosec 2x equals what? By using the direct substitution, we get 5 times 0, 0 times cosec 0. This equals 0 times infinity and specified value. So limit 5x cosec 2x. Cosec 2x is the reciprocal of sine 2x, so we can write our function as 5x over sine 2x when x tends to 0. So the limit of the function in this form equals 5 over 2. So our limit is 5 over 2. So the correct answer is 5 over 2. The next, limit when x tends to 0 for 3x plus 2 x power negative 1 over x plus for x power negative 1 equals what? By using the direct substitution, we get 0 plus, and find infinity over 0 plus infinity. This equals infinity over infinity and specified value. So we have to remove the 0 factor between the numerator and the denominator. We can do that by taking x power negative 1 as a common factor. From the numerator, we get limit x power negative 1 as a common factor, we get 3x divided by x power negative 1 is equal to 3 power x power 2 plus 2 over, take also x power negative 1 as a common factor. From the denominator, we get x power negative 1 divided x divided x power negative 1, we get x power 2 plus 4. Cancel x power negative 1 with x power negative 1. When x tends to 0, we get the limit by using the direct substitutions equal 2 over 4, which equals half. By using the direct substitution to get half. Okay. Another exercise. F is an odd function on the interval, close the interval, negative x and x, then f negative x plus fx. Since f is odd function, we know that f odd function means f of negative x is equal to negative fx. F and only f, fx is odd function. So f of negative x plus f of x is equal to negative f of x plus f of x. This equals 0. So we get 0. The next, if the area of triangle ABC is x and the radius length of the circumcircle is r, then the expression for rx over a times b times c equals what? From the sine rule, we know that a over sine a is equal to b over sine b equals c over sine c equals 2r. Also, area of triangle ABC equals half times a times b sine angle c, also equals half times a times c sine b, also equals half times b times c sine e. So for rx, we can write it as 2 times 2r times x, which is the area of the triangle ABC. This equals 2 times, we can replace 2r by any ratio of the given ratio, a over sine a or b over sine b, c over sine c from the sine rule. Let 2r equals a over sine a. 2 times, we get 2 times a over sine a times x. X is the area of triangle ABC, which equals one of the following expressions. I will choose the one in which sin A, which is number 3. So we get 2 times A over sin A times half BC times sin A. To remove sin A with sin A, also we can remove half with 2 to get A times B times C. This the numerator of the given expression. So the value equals A times B times C over A times B times C, which equals to 1. So the correct answer is 1. Okay. The next number of possible solutions of triangle ABC where measure angle A 60 degree, B equals 3 centimeter, A equals 5 centimeters. Log to angle A. Angle A acute angle, but A side A equals 5 centimeter, which is greater than B. A acute, but A greater than B, so B is only acute angle. Acute angle. So the number of solution is 1. We have one triangle. The next, ABC is an equilateral triangle. Its side length 5 root 3 centimeter. Then the diameter length of its circle equals ABC equilateral triangle. So A over sin A equals 2R. 2R represent the diameter length of its circle, which is the required. So 2R is equal to A equals 5 root 3 over sin 60. This equals 5 root 3 over root 3 over 2, which equals 10. So the diameter length of the circle is 10. If y equals a log a of x, then okay, we have y equals a log a of x by taking log a for the two sides. For the both sides, we get log a of y equals log a of a power log a of x. The left side will be log a of y. The right side down the power as coefficient of the log to get log a of x times log a of a. We know that log a of a equals 1, so log a of y is equal to log a of x, so y equals x. Y equals x means the difference between y and x is 0, so the correct answer C. The next, the one-to-one function from the following function is x power 2. We know x power 2 is even function, so it doesn't be 1 to 1. It can't be, doesn't be 1 to 1. Even function, it's a graph. As you see, if we draw horizontal line, it cuts it in more than 1 point, so x power 2 is not 1 to 1 function. X power 3 odd function, its curve, or it's represented by the following curve. So f of x equals x power 3, any horizontal line cuts it at only 1 point, so x power 3 is 1 to 1 function. Absolute x, even function represented by two rays, start with the point 0 and 0, so any horizontal line intersect it at more than 1 point. So the correct answer is B. The next, the vertex of the curve of the function f, where fx equals 2 minus x power 2 plus 3, quadratic function. F of x equals 2 minus x, we can write it as x minus 2 power 2, because x minus 2 power 2 is equal to 2 minus x power 2 plus 3. Its vertex is from the bracket we get 2, outside the bracket we get 3, so its vertex is 2 and 3. The next, fx equals 3x power 2 plus ax minus 2, and when x greater than 3, also equals 2x plus b when x less than 3. Limit fx equals 16 when x tends to 3, then a plus b. Since limit fx when x tends to 3 equals 16, and fx is piecewise function, so f3 positive equals f3 negative equals 16. So 3 times 3 power 2 plus 3 times a minus 2 is equal to 16, so 3a equals 16 minus 25 equals negative 9, so a equals negative 3. So also from f3 negative equals 16, so 2 times 3 plus b equals 16, so b equals 16 minus 6 is 10, so a plus b is equal to negative 3 plus 10 equals 7, so the correct answer is 7. The next, if the perimeter of triangle ABC is 33, sine A plus sine C equals 2 over 3, sine B equals quarter, then AC equals what? AC represent B. So from sine rule we get A over sine A is equal to P over sine B is equal to sine over sine C. From the properties of the proportional we get A plus C over sine A plus sine C equals one of the given ratio. So B, which is AC, over sine B, which equals quarter, is equal to a plus c. A plus c from the perimeter, we know a plus b plus c equals 33. So a plus c equals 33 minus b. So we can replace a plus c by 33 minus b over sine a plus sine c is given 2 over 3. So for AC equals 99 minus 3b minus b. For AC, b is AC, so 7 AC is equals to 99. Again, AC over 1 over 4 equals 33 minus AC over 2 over 3. Cross multiplication, we get 2 over 3 AC is equal to 33 over 4 minus AC over 4. Move to the opposite side, we get 11 over 12 AC is equal to 33 over 4, so AC equals 9 centimeter. So the correct answer is B. Another exercise, limit 1 minus cosine x plus sine x over 1 minus cosine x minus sine x. By using the direct substitution, we get 0 over 0. We know that limit 1 minus cosine x over x when x tends to 0 equals 0. Also, we know that limit sine x over x at x tends to 0 equals 1. By using the following rules, we can find the limit of the given function after dividing the numerator and the denominator by x. If we divide up by x and down by x, we get limit when x tends to 0, 4. 1 minus cosine x over x plus sine x over x divided by x up and down over 1 minus cosine x over x plus minus sine x over x. We take 1 minus cosine x over x plus sine x over x over 1 minus cosine x over x to be in the form 1 minus cosine x over x, and sine x alone over x to be in the form sine x over x. At x tends to 0, limit 1 minus cosine x over x equals 0 plus sine x over x is 1. At the denominator, limit 1 minus cosine x over x when x tends to 0 is 0 plus minus sine x over x when x tends to 0 equals 1. So the limit is 0 plus 1 is 1 over 0 minus 1 is negative 1. So we get the correct answer is negative 1. Another exercise. Okay, our questions are finished. Thank you.